All right, guys, let's run through some problems on the 11.2 worksheet. So this section was dealing with the surface area of the two more basic figures out there, which are prisms and cylinders, and that's what's going on in this problem right here. So we're being asked to find the surface area of this particular figure. As we look at it here, most of us can usually identify this one pretty quickly. It kind of looks like a cube, although the difference would be that in a cube, all three measurements there would have to be exactly the same. Here, what we have is a square on the front of this figure, and I say that it's a square because the sides are 6 and 6, they're the same, and we can see that we've got all right angles here on the back, which means the same on the front. But what happens here is that the depth of this figure right here is 8 miles, not 6 miles. So it's not technically a cube, this is actually a square prism. Now, lucky for us, though, we don't have to worry too much about that. The formula for surface area of any prism is always the same. So we're going to run with this, and here's step 1. Surface area of a prism is always going to be 2 times capital B, which remember now stands for area of the base, and we're going to add that to capital P, which is the perimeter of the base, and multiply that by the height of the figure. Now, the one tricky thing about dealing with prisms when we're doing surface area, specifically rectangular prisms, you actually have options here as to which of the faces of that prism that you want to call the base. Now, most people like to think of the base of a figure as being down on the bottom of it, and that's certainly not something that always has to be the case, but it can work in a shape like this. So let's approach it that way. If we were going to think about the bottom of this figure being our base, I'm going to go ahead and kind of shade that in right here like this. Okay, so if we've got this figure right here, if that's going to be a capital B, our base, the first thing we have to do as we move on to step 2 now is to figure out what the area of that base is right here, capital B. So what did we just do? We shaded in a rectangle that's got one side here at 6 miles, and this side right over here, we'll look for another one that it's parallel to. That would be 8 miles there. So 6 times 8 is going to get us 48 square miles for the area of that base. So that takes care of the capital B. Now we move on here. Plus, capital P means the perimeter of the base. So it's the same shape that we just looked at. And to figure that perimeter, let me switch colors on you right here. Let's think about it. We've got a side here of 6 and a side here of 8. That adds up to 14. Another 6 over here is going to get us to 20. And another 8 over here is going to get us to 28 for the perimeter. Actually, what I like to do in a case like that, in a rectangle, is to add up one of the short sides, 6, one of the long sides, which is 8, that got us to 14, and then just double that. All right, and that's how you can get to a 28 there. And this last concept is important here as well. And again, it's easy in this problem, but it's going to be harder in others. When we go to find the height of our prism, again, it's really tempting to think that height simply has to go up and down. And what's actually a little dangerous is that in this case, it does. That 6 miles right there is our height. But the way you really want to think about height, the real definition of it is that height is the distance between your two bases. Now, if we decided that the bases were this rectangle down here on the bottom, and then the other base would be this rectangle up here on top, then the reason that this 6 is the height is because that is the distance between those two bases. The height does not always run up and down. That's an important thing that we need to make sure that we understand properly. So we'll go ahead and put a 6 there for the height, and now I think step 2 is done. So let's go to step 3. Surface area equals, and let's do this together in our calculator. There's no reason we couldn't do all of this just in one big step, everybody. So we were taking 2 multiplied by a 48, that was the area of our base, and we were adding that to the perimeter of the base was 28, and we were multiplying that by the height of the figure, which was 6. Let me make sure I've got that right. 2 times 48 plus 28, plus 28 times 6. Yep, that's it. And that gets us our surface area here of 264. So let's write that answer down, and I want to talk for just a second here about units. Now, what I'm hoping you guys probably know by this point is that when they gave us units here in this problem of miles, miles is what we call a linear unit, linear meaning line. So if you were to just measure a distance between 2 points right here, you would do it in miles. Since we're talking about surface area, area is always a two-dimensional measurement, so our units here are going to be square miles. Actually, the reasoning behind that is a little bit more interesting. When we found capital B here, which was the area of the base, we got that by multiplying 6 miles times 8 miles right here. Well, miles times miles got us an area of 48 square miles. As we move to the right, the perimeter right here, the 28, that was just the sum of miles plus miles plus miles plus miles. And when you add all those miles together, you still just get linear miles. Our height right over here was 6 linear miles. And now let's take a look at what happened here. When we multiplied by order of operations, we did this first, the 28 times 6, we took miles times miles. And in doing that, we got square miles for these units right here, which we then added to these square miles right here that we got from area. And square miles plus square miles is going to get you square miles for your answer. So there's actually a mathematical reason for why the units are square miles, other than just the idea that that seems to make sense to us. Okay, let's move on to number 5, and this is where things start to get just a little bit more challenging for people in terms of trying to visualize what's happening within this prism. And I kind of gave it away there already, but here we go. Step 1, we are dealing with a prism. Why is that? Well, what I can see right here on the front of this figure is a triangle right there. And then directly behind it, I can see another congruent and parallel triangle on the opposite side of the figure, and then those are connected by these 3 little line segments right here. This is exactly what a prism looks like, everybody. So let's write this formula out in step 1. Surface area of a prism is 2 times the area of the base, because we have 2 bases, plus the perimeter of the base multiplied by the height. All right, so there's step 1. Let's move on to step 2. Surface area is equal to 2. We've got to figure out the area of the base. We don't know the perimeter of the base, nor do we know the height of that figure just yet. So we got a lot going on right here. All right, so let's switch some colors and try to stay organized here. Let me go to blue for just a second. We're going to try to figure out capital B, which means area of the base. Now again, we recognized, let me go back and erase some of this junk that I drew here. We recognized early on right here that there were 2 congruent and parallel figures on opposite sides of this solid. And that base then is this triangle that's located right over here. Now that right angle on the back also transfers onto the front. And what we have here is a triangle, a right triangle, with a side of 3, actually a leg of 3, and a leg of 4, so that didn't even have to really tell us that right there. That's a 3, 4, 5 right triangle. So for capital B, what we need to do is come up with the formula for the area of this blue triangle. Well, the formula for the area of a triangle is 1/2 times its lowercase base times its height. All right, so now within that blue triangle, let's remember something we did back in chapter 10, guys. Anytime you're dealing with a right triangle, the 2 legs are automatically perpendicular to each other. Those are the 2 sides then that you want to use for base and height. So we would go ahead and multiply the 3 times 4 to get a 12, and half of that would be 6. So the area of that blue triangle is going to be 6 square centimeters. I'll leave the units out right here, but that's how you'd come up with capital B. All right, let's move on. I'm going to switch to red now to try to come up with capital P. Capital P stands for perimeter of the base. Guys, it's really easy just to think P means perimeter, but you've got to say those words properly for you to understand what they mean and to remember to get it right. Perimeter of the base. So the base we established earlier is this right triangle on the front side of that figure. And our side lengths, we have a 4 centimeter leg here, a 3 centimeter leg down here, and a 5 centimeter hypotenuse right there. 4 plus 3 plus 5 looks like it's going to get us a grand total of 12 centimeters for the perimeter of that base. And let me switch to green now. The last thing to talk about here is the height, but again, say it right, height of the prism. And what height of a prism really means is distance between your bases. Okay, we have a triangular base on the front of this figure. We have another triangular base on the back of this figure. The height of the prism, as I said earlier, does not always get measured up and down. Height means distance between the bases. This little piece right here, 2 centimeters long, is the distance between those two triangular bases. So 2 is the height of that prism. One more time, height doesn't always go up and down. It's the distance between your bases. And now that we've filled in everything we need to know in step 2, I think we're ready to go to our calculator here and just type all this in step 3. Although actually, I'm going to do this one by hand. This isn't bad at all. The 2 times 6 is going to get us a 12. 12 times 2 is going to get us 24. And the 12 plus the 24 is going to get us 36. Since all of our linear measurements were given to us in centimeters, the surface area then is going to be 36 square centimeters. Okay, and that's the answer for number 5. So triangular prisms can be a little bit tricky. You've got to remember that the base isn't always on the bottom and the height isn't always measured up and down. All right, let's move on to number 9. And this is one that bothers people a little bit. As we look at this one right here and we try to identify the shape, this is one where it seems like we have ourselves 1, 2, 3, 4, 5 sides. So we've got a pentagon on the top of this figure. And as luck would have it, 1, 2, 3, 4, 5, we've got a congruent and parallel pentagon on the bottom of this figure. So this, everybody, is what you are going to call a pentagonal prism. It's got pentagons on both the top and the bottom, and those are going to serve as our bases. So for step 1, once again, we need the formula here for surface area of a prism, which is going to be 2 times the area of our base plus the perimeter of our base times the height of the prism. Step 2, let's start filling in what we know. Surface area is equal to 2 times, we do not know the area of the base, we don't yet know the perimeter of the base, nor do we know the height. So just like on the last problem, we've got some work to do. Capital B, area of the base, is usually the hardest thing to come up with. And for us right here, the base, we can go ahead and think about this one on the bottom here as being our base here. That is what we're dealing with. It's a pentagon. And the only pentagons we know how to find the area of so far are regular pentagons. We did this in sections 10.3, and we did them really pentagons in 10.5. Well, lucky for us, and I kind of wrote over it here, guys, but you've got tick marks here, 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 and here, indicating that these pentagons, including the blue one down here on the bottom, are regular pentagons because all 5 of those sides are congruent to each other. And that means that if we want to find capital B, that's the same formula we did back in chapter 10 for area of a regular polygon, which is 1/2 times its perimeter times its apothem. Now, coming up with that information there on a pentagon can be really, really difficult, but in these problems, they made this kind of easy for us right here. They told us that every side in this pentagon had a length of 8, and then this 5.5 right over here, that was our apothem. So this isn't going to be that bad. So the area of our base is 1/2 times our perimeter. Well, if each side is 8, and there's 1, 2, 3, 4, 5 of them, we would just take 8 times 5 to get 40 for the perimeter of our pentagon. And the apothem was given to us right here as 5.5 feet. So I'm going to go to the calculator here. I'll do this with you guys, and we're going to multiply out a 1/2, so that's 0.5, times a perimeter of 40, times an apothem of 5.5, and that gets us 110 for the area of that pentagon. 40 times 5.5. I forgot it already, sorry. 110, that's what it was. All right, so that goes right there. We just found capital B, everybody, right here, so that's going to be a 110. Okay, the rest of this should be pretty easy. Let me switch to, I think I did red next. Capital P for perimeter of the object right here. Again, it's perimeter of the base. Well, if we're looking at the same pentagon down there on the bottom as our base, that's going to be exactly the same perimeter that we came up with right over here. 8 times 5 is going to get us 40 for the perimeter of our base. And the last thing to think about here is the height of the prism. And the height of the prism means distance between the bases. This is the case you guys probably like best. The bases are on the bottom and the top of this figure, so the height is going to be measured vertically as the distance between those two bases. And that 5 feet right there is going to end up being our height. Okay, so let's switch back to purple right here. And now that we've got step 2 done, let's multiply everything out. So surface area is going to equal, what do we have here? 2 times 110 is going to be 220. The 40 times 5 right there is going to get us another 200. So 220 plus 200 is going to get us 420. Since all of our linear units were in feet, our area units are going to be square feet. So 420 square feet is going to be the answer for number 9. And I think number 10 works similar to that one. Okay, and finally now with this last one that I'm going to do with you, we're finally going to move on into cylinders for the first time. And a cylinder, boy, I don't like this diagram because one of these lines here, probably this one, depending on how you want to look at it, really should have been drawn as a dotted line right here because you wouldn't be able to see it. But that's what we've got right here. It is really just like a prism, except instead of having polygons on opposite sides of the figure, we have circles this time. Okay, so having identified that, let's use our new formula here. We haven't done this one yet together here in this video, that the formula for surface area of a cylinder is equal to 2 times pi r squared plus 2 pi r h. It doesn't really look like it, but that's actually the same formula we were just using for surface area of a prism for the last 3 problems. 2 times the area of the base plus the perimeter of the base times your height. And the reason those are the same is because capital B means area of the base. Well, in every cylinder, your base is a circle. So the formula for area of your base is the formula for area of a circle, which is pi r squared. The capital P here means perimeter of the base, but here, in a cylinder, your bases are always circles, and the perimeter of a circle is called circumference, and that formula is 2 times pi times r. You can see this 2 just comes straight down, this h just comes straight down, the capital B gets replaced by pi r squared, the capital P gets replaced by 2 pi r. And nobody really cares about that, but it's really the same formula. All right, step 2, let's fill in what we know. Surface area is going to be 2 times pi times a radius here of, well, that's information they gave us right here. We've got a line segment from the center of the circle to a point on the circle. 11 then is going to be our radius. So 2 times pi times 11 squared. Plus, here we go now for the lateral area, the sides here. That's going to be a 2 times pi. The good news is, guys, that this radius right here is always going to be the same as this radius right here. So that's still going to be 11. And h, just be careful right here, guys. Height does not always mean measured vertically. Height means distance between your bases. And the bases in a cylinder are your circles. So in this case, your circles are on the left and the right, so the height then is going to be measured horizontally between those two. That 8-inch measurement right there is the distance between the circular bases, so 8 is going to be your height. Now at this point, before we go ahead and try to answer the question, it's probably worth looking at our directions real quick, and it says the following: to round your answers to the nearest hundredth if necessary, but it really should have said this first, leave your answers in terms of pi for answers that contain pi. Now what that means, that's really a more important directive here rather than rounding. We're going to go ahead and put this in the calculator, and on a Texas Instruments calculator, one of the newer multi-views, you can go ahead and type everything in. But with what I'm using here, it's an older one, so I'm going to leave the 2 pi's out of the calculations here. Let me show you what I mean, guys. I'm going to do 2 times 11 squared. And then I'm going to add to that what was happening on the right, 2 times 11 times 8. So plus 2 times 11 times 8. And that gets us an answer of 418. So I'm going to write that down here, 418. And since I didn't include the pi's in my calculation, but that's a common factor, I just tag along at the end right there and stick a pi on it, just like you would with an x. 418 pi. Linear units were given to us as inches, so surface area is going to be measured in square inches. Okay. And that's our answer for number 13. Careful, because I think on number 14 they give you a diameter instead of a radius. So in that case, you're just going to take that diameter and divide it by 2 in order to figure out what r is. Okay, everybody, that is a good jump on the 11-2 homework. I think you can try those last 12 problems on your own. They should all follow pretty closely with what we did here. So good luck, and let me know if you have any questions.